Bismillah, alhamdulillah, wassalatu wassalamu ala rasulillah. Good morning, ya shabab. As we have agreed in the previous class, uh, our section 6.5, the last section in chapter 6, will be a flipped class. What I'm gonna do now, I will record the lecture for you and upload the slides in the Blackboard. You have to watch the recording and study the slides on Saturday. During the class time on Sunday, we will practice. We will not lecture. So 6.5 is a short section about a very basic idea, the average value of a function. So after finishing this section, you will be able, inshallah, to find the average value of a function and also to use it to apply the main value theorem for integrals. Let's start by, I think all of you, Shabab, know what we mean by average value of numbers. So if you have n numbers, you will sum them up and then divide by their number. So when you have finite numbers, or let's say finitely many numbers, you can find the average. This is not a problem, and this is not our target here, by the way. The question is, what about if you have infinitely many numbers and you want to find their average, like functions? For functions, for real valued functions, they have, of course, they are defined on real numbers. So the domain is sometimes all the real numbers. So how can you average them? So the question is how to compute the average temperature, for example, during a day, if infinitely many temperatures readings are possible. So when you have here, we have here infinitely many values for y. So how can we average them? This figure shows the graph of a temperature function, and we need to find out what is the average temperature. So our f here, the function here, is the temperature. طبعا in general, let's say that we have a function over a closed interval. How we can approximate, let's say approximate the average if we cannot find it exactly. What we will do, we will start by dividing this interval into n equal subintervals, the same way that we did when we calculate the area or approximate the area or approximate the volume. Each one of these intervals will have length equals to delta x equals to b minus a over n. You know that. Okay. So now what we will do, we will choose some symbol points from each subinterval, and we will calculate the average of the values of the function at these symbol points. Because here we have finite numbers of values, so it is easy to average them. Just add them to each other, find the summation of them, then divide by the number of them. We have n numbers. The average of them will be the sum of them over the number, their number. Now, what is n? Now, n, we will replace n, this n, we will replace it from here. So what we have here, we have this. So what is n? N is, what is delta x? Delta x is b minus a over n. So from here, if you solved this equation for n, you will do cross multiply. So n will be b minus a over delta x. Now come here, replace this n by b minus a over delta x. So this is what we are going to do. So we will, in this formula, we will replace n by b minus a over delta x. Now, of course, delta x, it is in the numerator of the denominator of the denominator. So just it will be the reciprocal. You will multiply by the reciprocal. So delta x will come here, and you'll have 1 over b minus a. You can, of course, now distribute delta x by expanding. So now we have the average of values of these functions is just 1 over b minus a times this summation. If you write this in sigma notation, look what you will have. you will have this, and this is a Riemann sum. If we let n goes to infinity, we will get the integral from a to b for f of x dx. This is by the definition of the definite integral. So when n goes to infinity, we will have this integral. So what is this equals to now? When n goes to infinity, it will be equals to the average value of the function. We started by approximating for some specific n, and we then let this n goes to infinity. So we have now the average value of this function. Let's summarize. The average value of the function f on this interval a and b. Of course, it should be a shabab integrable function. Continuity here will guarantee, of course, the integrability over this interval. So if we have a continuous function over this interval, then its average, we will write it shortly like this: f average equals to 1 over b minus a. What is this b minus a? It is the length of the interval. It is the upper limit minus the lower limit. So it is just the integral. You can say it in words like this: the average value of the function is equals to over closed interval. It is just the integral, the definite integral of this function from a to b over the length of this interval. It is it's a definite integral over the length of the interval that you are working on. So to find the average value of the function, just you need to find the integral, the definite integral, but don't forget to divide it by the length of the interval. Let's take this example. Find the average value of the function f of x equals to 1 plus x squared on this interval, negative a and negative 1 and 2. So this is a and this is b. So now the average of the function, it will be what? Just it will be 1 over b minus a, the integral from a to b f of x dx. What is a? A is negative 1. What is b? B is 2. Just substitute what you will have. It will be 1 over 2 minus negative 1. So it will be 2 plus 1. The integral from negative 1 to 2 for 1 plus x squared. This is f of x dx. Now simplify this. It will be 1 over 3. 1 over 3. Now what is the integral of 1 plus x squared? The integral of 1 is x. The integral of x squared, it is x to the power 3 over 3. And of course, it will be evaluated from negative 1 to 2. What we will do, we will substitute the upper, then minus substitute by the lower. So you will have here what? You will have a third, and here you will have 2 plus 8 over 3. This is when you substitute by 2, minus open brackets and substitute by negative 1. So you will have negative 1 plus, it will be minus 1 over 3 when you substitute. Now simplify. This will be third, and here you will have 6 plus 8. It will be 14. You will have 14 over 3 minus, or you can keep it, by the way, I have another, a better idea. Just do it like this. This will be plus 1 plus third. This will be equals to what? This is 2 plus 3. This is the third. This is 2 plus 1. It will be 3. Add the integers at the beginning. Then you have 8 plus 1 is 9. 9 over 3 will be 3. So you will have 3 plus 3. What is 3 plus 3? It is 6. 6 over 3, it is 2. So you will have third times 6, which will be 6 over 3, which is 2. It is important, Shabab, to practice the calculations, because you know you have a multiple choice exam. These steps are important. And it needs practice to deal with the calculations to be more professional. Okay, now if you look at it geometrically, it is important also to have an idea about, to visualize this issue, what we are talking about. So this is a function, you know how to sketch 1 plus x squared. It is just x squared shifted up 1 unit. From negative 1 to 1, this is the region that is bounded by this, below this graph of this function and above the x-axis. Look what we have found, that the average of the function is 2. So this is y value. We are talking about y equals to 2. Y equals to 2, if this is 0, this is, let's say this is 1, this is 2. So look, from here, the function starts here, start at -1. At -1, if you put x of x -1, you will have 2. Then it goes down until here when x is 0, it is 1. Then it goes up, here it comes back to 2. Then it continues up to 5. At 2, the interval, the right end point, when you have 2, it is 5. So look at the values of the function. They have changed from where to where, from 2, then decreasing to 1, then increasing to 5. What will be the average value of the function? We have found that the average value is what? Is 2. So you can think about that this value here, this value, اللي هي y equals f of 0, sorry, f of -1, and f also of what? F of 1. Also, it is the same as the value of the function at 1. These two, at these 2 points, we have the average value. So it is 2. The average value, it was starting from 2 up to where? Up to 5. And we found that the average value is 2. If you look at it, I will explain this in the next slide by using the main value theorem. So I will repeat that when we have, so what you can look at the average value of the function, just it is the value that is give you the average of the values that are varying from 2 to 1, from 1 to 5. We did find that most of the values can be averaged to 2. As a result of the average value, we have the main value theorem for integrals. It is quite similar to the one that we had for derivatives, if you remember, in MATH101. So if the function f is continuous over a closed interval, the continuity will guarantee the integrability. Then there exists a number in this interval. So here we have a number c between a and b. It could be a, it could be b, by the way, no problem. Such that the average value of the function that we did in the previous slide is equals to the value of the function at that number. So there is a number between a and b such that the value at this number, the value of the function at that number equals to f average. Of course, you have now what we have now. So what is this saying? That says that f of c will be equals to what? 1 over b minus a equals to the integral from a to b f of x dx. Now, if you did just cross multiply, if you multiply both sides by b minus a, you will have this. You will have b minus a multiplied by f of c equals to the integral of f of the function from a to b. And so we have what? We have now this theorem. And as I said, Shabab, why I mentioned that it is quite similar to the derivatives, because if you remember, for derivatives, we had it, of course, here, f of c multiplied by b minus a, and here we have the derivative of the function at c equals to this number. And it is just another way to say that the average value of the function equals to the value of the function at some number between a and b. That's it. So remember mainly this form, which is just quite similar by cross multiply. Let's apply it now, or before, let's see what does that geometrically mean, because I mentioned this in the previous slide. So in general, geometrically, we can look at it. Let's assume for simplicity that we have a positive function f. Then, as by this theorem, if the function is continuous, then there is a number c between a and b such that this is the number c between a and b such that the value of the function at c, so here this is y equals f of c. You can think about it like the height here, f of c, is of course the same as the average value of the function. Then if you look at it, it will be just the area. It has an area. This is a rectangle. We have here a rectangle. Its width is b minus a, and its height is f of c. So what will be its area? Its area, the area of this triangle, will be just f of c times b minus a. F of c times b minus a. And this is exactly equals to what? Look here. What is this equals to? It is equals to the integral of the function from a to b. So let's repeat that. here we say that the geometrically the main value theorem means that there is a number C such that the rectangle with base equals to b minus a and height equals to f of c, which is the average value of the function, has the same area as the region under the graph of f from a to b. Now the area here, look at the area shabab in blue, the area under this graph, it will be equals to the area of this rectangle. What is this rectangle? It's just b minus a multiplied by the average value of the function, by the value of the function at c at some numbers. So this is geometrically what does the main value theorem means. Let's apply it now, the main value theorem, for the same example that we had in example number 1. So the same function that we had in example number 1. F of x equals 1 plus x squared. We know that it is continuous on this interval. This is just example 1, the same function, the same interval of example 1. Because it is continuous on this interval, then the main value theorem for integrals says what? It says that there is a number between -1 and 2 such that the integral of this function from -1 to 2 will be equals to f of c times b minus a. If you remember, just it is this one. We are applying this one. Okay, so in this case, this is our integral. We have f of x from a to b dx equals to f of c. What is c? C is some number between a and b times b minus a. Now in our case, this is a, this is b, and this is the function, and this is also, of course, the limits of the integral. Now in some situations we can find what is exactly c, but not in general. I think in this example we are lucky, we can find c. Let's see what we can do about it. Now we are lucky, we can find this integral. It is not difficult. We did indeed, and we did that in the previous example. So now, as I said, in this particular case, we can find c explicitly. We did, ya shabab, find from the example number 1 that the average value of the function is 2. So this means that f of c is 2. Because we said, of course, that here, that f of c will be equal to the average value of the function. So here we know what is f of c. It is 2. And we have the function. The function is f of x is 1 plus x squared. So what is f of c? Will be 1 plus c squared. And we say that f of c is 2. F of c is 2. So we will have 1 plus c squared equals to 2, which means that c squared equals to 1, which means that c equals to positive or -1. So we have, in fact, instead of 1 c, we have 2 c's here. So it is at least 1. It should be mentioned here. It is, isn't it mentioned? Then there exists at least a number. It should be like that, at least one number, because we could have more than 1. Okay, so c equals to -1 and 1. Do you recall the graph that we showed you in the previous example? Now I think it will be more clear for you. You need to check, by the way, if you got the values of c, you must check that they are inside this interval. If they are not, reject them. So this is also one of the main conditions on the main value theorem, that the number must be within the interval that you are integrating on. Now, if you remember, this was the geometry of this problem. We say that the average value of the function is 2, and we have it at 2 x values. We have it at -1, and we have it at 2. So this is c, -1 and 1 inside this interval. Okay, and again, if you calculate now the area of this rectangle, it will be the same as the area under this graph. Just let's do it. What is the length? What is the width of this rectangle? It is 2 minus -1. It will be 3. And what is the height? The height is 2. So what is the area? The area will be 2 times 3, which will be 6. If you find the area of this integral from -1 up to 2, from -1 up to 2 for the function 1 plus x squared dx. I think we did that in the previous one. It was what? It was 1 x plus x cubed. It will be x plus x cubed over 3 from -1 to 2. We did find that it was 6, and then we divided by 3 by the length of the interval. So it will be what? It will be 2 plus 8 over 3 minus, it will be minus 1, it will be plus 1, and this will be also minus 1, it will be plus 3 over 2, 1 over 3, -1 over 3. I did it quickly here, Shabab, because I think it is clear. We did it here in the previous example. Avoid any mistake here by doing this minus and open bracket. So you will have -1 plus -1 over 3. This will be equals to 2 plus 8 over 3 plus 1 plus 1 over 3. And this is, of course, 2 plus 1 will be equals to 3. And 8 plus 1, it will be 9. 9 over 3 will be 3. It will be 6. So you can, of course, with the help here of the mean value theorem, you can, of course, find the integral under this graph if you know what is the average value of the function. And this is easy here because we have positive functions. This is just for simplicity. This is all what we have, Shabab. To summarize, what you need to recall mainly from this section is what is the average value of the function. And of course, you will have many questions. I can give you a question from any section from now until the end of the course. I can give you any integral. I will just give you a function that is continuous, and I will ask you to find the average value of the function. So what you will do, you will just integrate, find the definite integral, then divide it by b minus a. This is the only difference that you will do. So instead of saying integrate or find the integral of this function, I can ask you find the average value of the function. And you need to do the integral, and you need to divide it at the end by the length of the interval that you are integrating on. So this is the average value of the function. If we are talking about the mean value theorem, which is of course just an application for the average value of the function, it says that if you have a continuous function or closed interval, then there must be at least one number inside this interval, or even one of the endpoints, at which the value of the function will be equal to the average value of the function. In other words, the integral of the function will be equals to the value of the function at that number multiplied by the length of the interval. This is what I want you to recall more when we are talking about the main value theorem of integrals. That's it, ya shabab, and see you inshallah tomorrow not tomorrow, on Sunday inshallah in the class. During the class of Sunday, we will practice by solving many exercises, also the recitation problems, and also all the exam question and the textbook exercises to practice on this section. Of course, you need to focus also more on the integrating techniques, how to find the integral, because what we will do, we will just find the integral and then divide it by b minus a. See you then, ya shabab. Assalamu alaikum wa rahmatullah.